Hello, welcome to the new series of videos. In this series, we are going to see induction motors. I want to first begin by explaining the working principle of induction motor, and step by step, we will build first the stator, and then we will look at the rotor, and so on. Especially in this video, I will explain how the stator is constructed and how its winding is done. By the way, typically induction motor will be like a three-phase motor. There are single-phase motor also, but the three-phase, which is like a natural starting point to run induction motors. So I'll deal with as a three-phase motor in this series. Okay, so let's get started. Okay, so let's think how the stator is constructed. Stator, as you know, is a stationary part. So there is a base, like on the top the system motor is there. And this is cross section, so circular as a motor. And it's fixed to the base, some kind of stance, like this. It's completely fixed using some nuts and bolts. That means just this particular stator does not move. Now, inside the stator, we have a slot. Slot something like this. By the way, I'm drawing very rough here. Later, I will make a more accurate diagram. All right. So this part is stator core. Stator core glue made up of magnetic material, and it will be laminated to reduce losses. Now, inside the slot, we insert the conductors. And these conductors constituting the stator winding. So how the stator windings are connected? How exactly it is connected? Well, we'll have proceed more detail at the accurate diagram later. So for now, it's just a three-phase winding. So totally coming out like, let's say, ABC, I have an A phase, B phase, and a C phase. And in the stator side, they all interconnected, short-circuited. So since this is a motor, so input is electrical, so we can connect some, three-phase AC supply. And the supply will be connected to the stator winding, and then stator is energized. So what happens whenever three-phase supply is connected to the stator windings in this fashion? Rotating magnetic field is created. Rotating magnetic field is created. This is as the same principle as this experiment, just as explained in the previous video. So I'll explain why rotating magnetic field it will be created because of the three-phase winding, precisely. So for that, first we should to understand how these conductors themselves connected in the stator winding.
So let's continue. Now, let me draw a more accurate diagram. Last one is just a rough diagram. Now, to begin with, we have a three-phase, and I want to show as an example of a two-pole stator. So these are two magnetic poles. That means there will be one north pole and one south pole. So together we have a two-pole winding. Now, you may ask, where is a magnet? I'm saying rotating magnetic field is as created as an imaginary pole. Two poles, so one half become north pole, other half becomes south pole. They together form a magnetic field, and then they will be rotating. We'll come to it. Three phase, two poles. Now, how many total slots are there? So let's assume there are 12 slots. Then we need to calculate quantity, which is called slot per phase per pole. So we have a 12 slot divided by 3 phase times 2 poles. That is 2. That means I have to locate 2 slots per phase for every pole. Just remember this here too. So let's draw the slot first. I will begin by drawing conductor first. So my reference, drawing vertical, horizontal line. This is just for my reference. See, there are 12 conductors. They are into 4, so each conductor will be 3 into each quadrant. So I put one conductor here, another conductor here, another conductor here, 3, and 4, 5, and 6, 7, 8, and 9, 10, 11, and 12. Okay? And the stator core, just write it quickly. Okay, we are creating slot in the stator, so this entire thing becomes stator core. Let's give some whole area is made up of magnetic material, which is having the stator core. So let's give some numbers. Let's say this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Or as a mechanical angle between each of these. So angle between 1 and 2 will be 30 degrees, 2 and 3 will be 30 degrees, and so on. I think just go with 360 degrees divided by 12 slot. Now remember this number slot per phase per pole. If I think of entire right side, it's become one pole, and another side becomes one slot. I have to locate. What I can do is slot 1 and 2. I can locate A phase. 3 and 4 I can locate B phase. 5 and 6 I can locate C phase. This entire right side become a one pole. North pole, for example, and the another pole on the left side. And again 7 and 8 I can locate A phase. 9 and 10 I can locate B phase. Slot 11 and 12 again I can locate C phase. So we have located the slot, the conductors. So we have also located the conductors. So the conductors 1 and 2, 7 and 8 belongs to A phase. How are they connected? As you see, this is a cross section. But actual structure of the motor, it will be cylindrical shape. It will be cylindrical shape. So the one runs into the length of the stator. Also 2 runs into, 3 runs into, and so on. Just this is just giving you the 3-dimensional view. Then I have prepared another sheet like this. Basically, what happened is this. This is a developed version of this winding. This winding is arranged circularly. So I turn this paper like this, and then align number 1 and 12, and retrieve camera circular. So I open it up and I get the winding in. Now how this electrical connection are created. I have some location here. Okay, so let me stop here. Thank you so much for watching and see you next time.